Good morning, students. Explain different types of error. Okay, this was asked in previous university exams. ഇങ്ങനെ ക്വസ്റ്റ്യൻ വന്നാൽ ഞാൻ നേരത്തെ പഠിപ്പിച്ച തന്നെ ഇൻപുട്ട് ക്വാണ്ടൈസേഷൻ അതൊന്ന് നോട്ട് ചെയ്ത് വെച്ചോ. ഇൻപുട്ട് ക്വാണ്ടൈസേഷൻ എറർ, പ്രോഡക്റ്റ് quantization error and coefficient quantization error. ഓക്കെ, ഈ 3 ടൈപ്പ് എറേഴ്സിനെ പറ്റി ഒന്ന് എക്സ്പ്ലെയിൻ ചെയ്യാം. ഓക്കെ, ഇത് സ്ഥിരമായിട്ട് ചോദിക്കാറുണ്ട്. എറേഴ്സ് ഏതൊക്കെയാണെന്ന് ചോദിച്ചു കഴിഞ്ഞാൽ നിങ്ങൾ എഴുതേണ്ടത് ഇൻപുട്ട് ക്വാണ്ടൈസേഷൻ, പ്രോഡക്റ്റ് ക്വാണ്ടൈസേഷൻ ആൻഡ് കോഎഫിഷ്യന്റ് ക്വാണ്ടൈസേഷൻ. ഓക്കെ, now you will do some problems. Explain the characteristics of a limit cycle oscillation with respect to the system described by the difference equation. System described by the difference equation y of n equal to 0.9 y of n minus 1 plus x of n. Okay, this is the given difference equation and you have to calculation. Okay, also you have to determine the dead band. Okay, you have to determine the, in case നിങ്ങൾക്ക് ന്യൂമറിക്കൽസ് ചോദിച്ചു കഴിഞ്ഞാൽ ചെയ്യാൻ അറിഞ്ഞിരിക്കണം. ഓക്കെ, മോസ്റ്റ് പ്രോബബിളി തിയറട്ടിക്കൽ ക്വസ്റ്റ്യൻസ് ആണ് വരുന്നത്, എന്നാലും നമുക്കൊരു സേഫ് സൈഡും കൂടെ നോക്കണമല്ലോ. ഡിറ്റർമൈൻ ദ ഡെഡ് ബാൻഡ് ഓഫ് ഫിൽറ്റർ. Okay, this is a question. Please note this question. Okay, now let us assume 4-bit sign magnitude. Okay, let us assume 4-bit sign magnitude representation. And also we can assume the input. Okay, we can assume the input, or let the input be x of n equal to 0.825 for n equal to 0 and 0 otherwise. Okay. Okay. Now because of finite length register, the product zero point 0.9 y of n minus 1 in the difference equation must be rounded to 4 bits before adding to x of n. Okay. Before starting the problem, you have to round the product. Okay, round the product. Okay, because of finite length register, because of finite length register, the product 0.9 y of n minus 1 in the difference equation must be rounded to 4 bits, rounded to 4 bits before adding to x of n. The output y of n with rounding is given by y of n equals x of n plus that is point. Okay. Okay, now you have to find the value of this y of n when n equal to 0. 0 equals q of plus x of 0 equals 0.825. Okay, 0.25 by when n equal to 0. Okay, next you have to put the value n equal to 1. N equal to 1. So y of 1 will be equal to q of 0.9 y of 0 plus x of 1. Okay, then what happens is that earlier we got the value of n equal to 0, that is y of 0. Substitute for this, and then what happens, q of 0.9 into 0.825 plus 0. Okay, plus 0, then it will become q of 0.7425. Okay, 0.7425. That is, we can represent this 0.7425 as 0.101112. Okay, and after rounding we get this as 0.7425. Round ചെയ്ത് എന്ത് ചെയ്യും? 0.1100. Okay, that is 0.75. അതായത് 0.7425 നമുക്ക് റൗണ്ട് ചെയ്ത് 0.75 ആക്കാം. Therefore, we got y of 1 as 0.75. Okay. Similarly, you have to find the value of n equal to 2. That is y of 2. Okay. Y of 2. That is y of 2 will be equal to q of 0.9 y of 1 plus x of 2. This should be equal to q of 0.9 into 0.75 plus 0. That is q of 0.675. That is you have to round the 0.675. Okay. 0.675 can be written as 0.101011. After rounding, you will get it as 0.675 will be equal to 0.10112. That is 0.6875. Okay. Rounding ഫസ്റ്റ് ഞാൻ പഠിപ്പിച്ചില്ലേ ഇതിൻ്റെ ഫസ്റ്റ് ക്ലാസ്സിൽ ആ സെയിം പ്രൊസീജിയേഴ്സ് ആണ് ഇവിടെയും ചെയ്യുന്നത്. Therefore, you will get y of 2 as 0.875. Okay. Then n equal to 3. That is y of 3 will be equal to q of 0.9 y of 2 plus x of 3 equal to q of 0.9 into 0.6875 plus 0. Okay, that is q of 0.61875. So we can write it as 0.61875 as 0.1001111. Similarly, you have to round this value. After rounding, you will get it as 0.61875 10 as 0.1010. Okay, that is 0.62625. Okay, therefore, you can write y of 3 as y of 3 as 0.625, and therefore similarly you have to write for n equal to 4 also. Okay, n equal to 4, n equal to 5 till n equal to 8. Okay, you have to write till n equal to 8. Okay, then n equal to 4 ആകുമ്പോൾ you will get y of 4 as q of 0.5625, and converting this value you will get it as 0.10012. After rounding, you will get y of 4 as 0.5625. Okay, and for n equal to 5, you will get y of 5 as q of 0.50625. Okay, and after rounding you will get it as y of 5 equal to 0.5, 0.5. Okay. Similarly, n equal to 6, you will get it as y of 6 equal to q of 0.45, and after rounding you will get it as final answer of y of 6 will be 0.4375. Okay. Okay. Then for n equal to 7, n equal to 7, y of 7 will be equal to q of 0.39375. Okay. And after rounding you will get it as 0.375, and similarly for n equal to 8, y of 8 will be q of 0.3375, and after rounding the final answer will be y of 8 equal to 0.3125. Okay. Now after analyzing these values, that is till y of 0 to y of 8, the output is varying. Okay, the output is varying. That is, each values of y of 0 till y of 8 has different values. That is, no, it's not constant value. Okay, it has no constant behavior. Okay, it has no constant behavior. Therefore, what happens? It means that there is no limit cycle occurring. Okay, there is no, this no constant behavior represents the fact that there is no limit cycle behavior. Okay, that means that the dead band does not exist. Okay, there is no dead band. Okay, dead band, because all values of y of n, okay, from y of 0 to y of 8 has varying values. There is no constant values. Okay, therefore there is no dead band occurrence. Okay, there is no dead band. Okay. This question has no dead band. Now we will do a question with the dead band. Okay. Now we will do a question with the dead band. Now write this question. Explain the characteristics of a limit cycle. Limit cycle oscillation with respect to the system described. With respect to the system described by different situation, y of n equals 0.97 y of n minus 1 plus x of n. Okay, plus x of n. And you have to determine the dead band of filter. Same as the earlier question, you have to first assume the 4-bit sign magnitude representation and also the input as the x of n equal to 0.8. Okay, 0.85. Okay, same input you have to assume. Therefore, let us assume 4-bit 4-bit sign magnitude representation and let the input be x of n equal to 0.85 for n equal to 0 and 0 otherwise. Okay, as the same fact, you have to round the product. Okay, you have to round this product before you have to find the value of I of n. That is, first you have to find the uh, value when n equal to 0. Before that, you have to write the output y of n as x of n plus q of 0.97 y of n minus 1. Okay, and for n equal to 0, y of 0 equals q of 0.97 y of minus 1 plus x of 0. This will be equal to 0.885 itself. Okay. Okay, then when n equal to n equal to 1, y of 1 can be written as q of 0.97 y of 0 plus x of 1. Okay. Therefore, this will be q of 0.97 into y of 0 is 0.85 plus 0. Okay, this will be equal to q of 0.8245. This can be represented as 0.8245 can be represented as 0.110100. Okay. And after rounding, we get 0.8245 will be 0.11012. This will be again equal to 0.8125, and therefore finally we will get the value of I of 1 as 0.8125. And for n equal to 2, y of 2 will be equal to q of 0.97 y of 1 plus x of 2, which will be equal to q of 0.97 into 0.8125 plus 0, and hence this will be q of 0.788125. and we can represent this value as 0.788125 will be equal to 0.11000100, and after rounding you will get the value of y of 2 as 0.7510. Okay. Similarly, you have to find the value of n of 3 also. Okay. N of, that is n equal to 3. While doing n equal to 3, you will get it as y of 3 as q of 0.97 y of 2 plus x of 3, which will be equal to q of 0.97 into 0.75 plus 0 and q of 0.7275, and therefore 0.7275 can be represented as 0.10112, and after rounding you will get it as 0.7275, should be equal to 0.11002. Okay. Again, y of 3 can be written as 0.7510. Okay. Okay. Now it can be seen that the y of 2 and y of 3 are similar. Okay. Both of them has the same values, that is 0.75. So from above calculation it can be observed that it can be observed that for n greater than or equal to 2, the output remains constant. Okay, for n greater than or equal to 2, that is n equal to 2 and n equal to 3, it is observed that the output remains constant. Okay, the output remains constant at what value? 0.75. Okay, at 0.75, causing limit cycle behavior. Okay, therefore there exists a limit cycle. Okay, therefore there exists a limit cycle. Okay, and the limit cycle can be found out using the given equation, or there exists limit cycle, and therefore there is also dead band. Okay, that is also dead band. One minus okay, first we can write dead band as 1 by 2 into 2 raised to minus 4 divided by 1 minus 4 equation, that is y of n equal to 0.97 y of n minus 1 plus എത്ര കിട്ടും ഇത് 0.0416. So the dead band will be 1.0. Now, നമ്മൾ കഴിഞ്ഞ ക്ലാസ്സിൽ റെസിഡ്യൂ തിയറി അല്ലെങ്കിൽ റെസിഡ്യൂ മെത്തേഡ് വെച്ചിട്ട് വേരിയൻസ് കണ്ടുപിടിച്ചായിരുന്നു. ഓക്കെ, ഇനി അതിൽ നിന്നൊരു ഒരു പ്രോബ്ലം നമുക്ക് നോക്കാം. ദാറ്റ് ഈസ് ഓവർഫ്ലോ. ഓക്കെ, വി ക്യാൻ ഡു എ പ്രോബ്ലം ബേസ്ഡ് ഓൺ ഓവർഫ്ലോ. Okay, before that, write a question. Given h of z equal to 0.2 plus 0.6 z raised to minus 1 by 1 minus 0.28 z raised to minus 1. What is h of z? The transfer function of a digital filter. Okay, you have to find the scaling factor S0 at input to avoid overflow in adder. Okay, you have to find the value of S0 at the input to avoid the overflow in the adder. Okay, before that, the question is given as the transfer function of a digital filter. Okay, ആദ്യം ഈ തന്നേക്കുന്ന എച്ച് ഓഫ് ഇസഡ് എന്ന് റിയലൈസ് ചെയ്ത് എങ്ങനെ റിയലൈസ് ചെയ്യും? You can realize ഇത് റിയലൈസ് ചെയ്യുമ്പോൾ നമുക്ക് കിട്ടുന്നത് ഇങ്ങനെ ആയിരിക്കും. This will be the realization of the given h of z. Okay, and this will be the s of 0. You have to find s0 such that you have to find the scaling factor S0 at the input. Okay, ഇൻപുട്ടിലെ S0 ആണ്, അതായത് ഇൻപുട്ടായ എക്സ് ഓഫ് എന്നിലെ S0 ആണ് കണ്ടുപിടിക്കേണ്ടത് ടു അവോയ്ഡ് ദി ഓവർഫ്ലോ ഇൻ ആഡർ. ഓക്കെ, ഓവർഫ്ലോ കണ്ടീഷൻ അവോയ്ഡ് ചെയ്യാനായിട്ട് എത്രയാണ് സ്കെയിലിംഗ് ഫാക്ടർ S0 എന്നുള്ളതാണ് കണ്ടുപിടിക്കുന്നത്. ബിഫോർ ദാറ്റ് വി ഹാവ് S0 square as 1 by I, and where I can be written as 1 by 2 pi j the integral of z inverse dz by d of z and d of z inverse. Okay, this will be the equation. ഒന്ന് എഴുതിയെടുത്തോ equation. And d of z എന്താണ്? തന്നേക്കുന്ന h of z ന്റെ ഡിനോമിനേറ്റർ ആണ് ഉദ്ദേശിച്ചത്. d of z എന്താണ് ഡിനോമിനേറ്റർ? 1 minus 0.28 z inverse. ഓക്കെ, ഇനി ഈ വാല്യൂ ഐയുടെ വാല്യൂ കണ്ടുപിടിച്ചേ. I can be written as 1 by 2 pi j into Z inverse by 1 minus 0.28 Z inverse 1 minus 0.28 Z അല്ലേ Z ഇൻവേഴ്സും Z കൂടി മാറ്റിയിടൂ into dz. Okay, this can be found out using the residue method. Residue method is sum of residues of Z inverse by 1 minus 0.28 Z inverse into 1 minus 0.28 Z. Okay. And poles ഏതൊക്കെയാണ് ഇക്വേഷനിൽ poles due to poles at Z equal to 0.28 and Z equal to 1 by 0.28, that is 3.57. These are the poles, and we can eliminate this 3.57. Okay, because 3.57 means it is outside the unit circle അല്ലേ, 1ന്റെ മേലെ അല്ലേ ഇത് കിടക്കുന്നത്, അപ്പോൾ നമുക്ക് ഇത് എലിമിനേറ്റ് ചെയ്യാം. Therefore we have to find out the residue at Z equal to 0.28. For that you have to write the equation as I equal to residue of Z inverse by 1 minus 0.28 Z inverse into 1 minus 0.28 Z at pole Z equal to 0.28. Okay, കണ്ടുപിടിച്ച് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്താൽ പോരെ എല്ലാം. Equal to Z minus 0.28 into 1 by Z minus 0.28 into 1 minus 0.28 into Z at Z equal to 0.28. After substituting, you will get it as I equal to 1.085. 1.085. And you have to find the value of S0. That is S0 can be found out by the equation 1 by root of I. That is 1 by root of 1.085. That is 0.96. Therefore, this is the scaling factor at input to avoid the overflow in the adder. Okay.